Oh, perfect. Thank you. All right. I'll just put this over here on my other monitor.
I want to ask something.
Yeah.
I can't remember what week it is. It's like, I don't know, week like 12, 13, or 14. Like it goes over classes. Once we reach that point, could we go back to what was it? The vectors homework, the one we did just yesterday,
Oh,
just 2 days ago? Because I'd love to go more thoroughly, like how it's sort of like that'd be like a good example, no?
oh, are you talking about this homework problem here?
No, the lab assignment.
Oh, the lab assignments.
Because I was watching the video later just so I can get like a better understanding of it. And you were saying, oh, we wouldn't understand this during the thing itself, the session. It didn't even it introduced classes without introducing them, so it's trippy to see.
Oh, is there a particular lab in the vectors section that you wanted to look at?
The one we did about the playlist.
Oh, you're talking about pointers, not vectors.
Yeah, that one. Sorry.
Yeah, because I was gonna say vectors. We did that a long time ago. Like, but yeah, yeah, it was kind of. I kind of had a hard time choosing which one of these labs to give to you because I'll just show you all of them.
I'm guessing they all involve classes because
Yeah,
all
they
the
all involve
examples they
classes.
get. Yeah.
Look how much this one involved. I did not want to give this to you. Like,
wow.
absolutely not. And then if I go over to the next one, this one. Well, this was not too bad, but it did ask you to write 3 different things. And that was the reason why I decided to give you a 9.8 because it required the least amount of work. But yeah, you were right. It did talk about classes first before you even learned it. But
yeah, that was definitely a trippy feeling because my god, man, a lot of new instructions that have never been used before were being introduced.
Yeah, there's a lot. Like, for instance, one thing you didn't learn yet is that like, even though you could have this is all class code, everything in the header file and everything in the CPP file, this is all class. This all pertains to the song node class. You could have it all be in the main.cpp file, but having it in separate header and CPP files just makes it more organized. That's one thing you didn't learn yet. And another thing, header files just list the contents of the members of the class, but the CPP file defines what each member is. Like, this is a constructor, this is a constructor, so on and so forth. I imagine that we'll learn this all when we get to this. But yeah.
But basically, like once we reach that point, could we go back to this lab and then you can just, instead of just reading through the class thing, you can just explain what each of these things are?
Sure. We can do that. But the first thing I'd like to do is for this.
Yeah, this one, yeah. Like the homework.
Yeah. I did want to talk to you about the homework. Problem 3. I actually looked at my email and I actually did get an email from Professor Amir in regards to question 3 because I was confused about it because I just kind of wish that he was a little more descriptive with these questions. And it turns out that when we did problem 3 before, I totally misinterpreted what the question means. And that's why I wanted to do problem 3 again today so that you guys can fix it and you don't lose points because of me. So he actually he actually gave me the solution that he's looking for. Now, a few things. We were right we were correct in the respect that we needed to use global variables to communicate to the functions the size of the two-dimensional arrays. But one thing that I completely screwed up on is that when it's asking checks whether all elements in the two-dimensional array are identical. When it says that, I looked at Professor Amir's solution. The code is checking two different two-dimensional arrays and checking each element one by one. Like, is this element in 2D array A it's the same as the elements in 2D array B? It's comparing it to each other. The code that we did, it was checking to see if every element in a single 2D array is the same. And that apparently is incorrect. So my bad. Like,
Did you ever get the chance to see the email I sent you?
Huh?
Did you ever get the chance to see the email that I had sent you with the link before?
Let me see. Oh, I don't want to show my email to you guys. Let me do this.
Yeah, well, it's just I was gonna say like the email I sent asked those questions too, and it said that like we need to do two separate arrays as well.
I'm sorry, but when did you send that email?
Tuesday.
Tuesday. So the 6th.
So I just forwarded, but I wasn't sure if it like arrived.
I'm sorry, Jose. So I did get this email from you. Oh, actually, that's actually to you. This is when you sent me the PDF. I'm sorry, Jose. I don't think I got that email. I'm sorry.
No, it's fine. I guess it didn't send. I thought I saw it, but just for now, I wasn't sure.
Okay. Well, anyways, let me put this back. But yeah, so if I were to change this question, I would say 2D arrays, not array, because when it says checks whether all elements in a two-dimensional array are identical, I thought we were looking at each singular two-dimensional array on a case-by-case basis, checking to see if every element in it is identical. I didn't know that we were cross-checking it with another 2D array. That's the reason why I gave you all that wrong code before. Yeah.
See, the thing about that too is that he didn't necessarily specify what size each of the 2D arrays had to be, and you kind of have to have the size of an array before you do anything with it.
Well, yeah, but that's okay because the way that we're gonna do that is with a global variable, and Professor Amir did say that we need to use global variables to solve this problem. The only thing that tripped me up is that he should have said arrays, not array, and that's why I gave you the wrong code before. But it's totally okay. We're gonna get this problem out of the way now, and we're gonna do it right this time, and then you can turn in your homework before midnight tonight, because that's when this is due, right?
Yeah.
Okay, perfect. So we're prepared to do the homework 3 problem again. And if you have the code that I gave you before for problem 3, apparently it's wrong. So please get rid of that and just look at what we're doing now. Okay? Because yeah, he should have said arrays instead of array, but it's okay.
Well, it technically says that. It's just that like the first sentence sounds like a single one. The second sentence sounds like multiple.
Test your code by printing out the 2D arrays and if they are identical or not. Yeah,
It says
he
they.
said arrays here, but he didn't say arrays. It's okay. We know now, so
So we need to start from scratch.
yeah, because I misinterpreted the instructions. I thought we were checking each element in a 2D in one 2D array to see if they were all the same. What we're actually doing is taking two two-dimensional arrays and cross-checking it with each other to make sure that they're identical.
Which problem is this again?
Problem 3.
Okay, thank you.
Yeah.
I think that says something if you misinterpreted it. It was kind of funny thinking how the rest of us were supposed to kind of figure it out.
I'm sorry, what was that?
Sorry, my mic has been going in. I was saying the fact that you misinterpreted kind of makes me wonder how the rest of us were kind of supposed to figure it out.
Yeah. Yeah, I would reword this to say that write a function that checks whether all elements in two-dimensional arrays are identical. That's how you should have said it, but it's okay. We know now. Well, anyways, without any further ado, let's get started on this. Let me make this a little bigger so you can see. Yeah. The way you word the question is very important, you know. Hopefully we can get through this quick so that we can start looking at the week 10 sections. Oh, someone's microphone keeps clicking. Yeah, I hear that too. All right. Okay, so as I said before, Professor Amir did give me his code. One of the differences between his code and mine is that he only uses one global variable, and that's for columns, and he says columns equals 3. But he doesn't use a global variable to find out how many rows there are. But I
Is
guess
that part supposed to be dynamic?
Huh?
Is that part supposed to be dynamic?
you
Or
mean
no?
are you asking if the number 3
Rows part.
because are you asking if calls equals 3 will change? Is that
No, because columns is the second one, no?
Yeah, rows then columns, yes.
Yeah, so rows needs to be dynamic, no?
Yeah, the number of rows can change, but the number of columns remains static. That's presumed throughout the program. And then I'm not gonna give you the code for his function. We can just do that together, but I will write I will write the first line of the function. He said this. Let me change this to that. So let's try to figure out how exactly this function works. So the way it works is that here is a function that returns a bool, right? the function is called values identical 2D. And it accepts two arguments. One is the 2D array itself, but the first bracket is empty, but the second bracket contains our Cole's global variable. And then the second argument that's passed is the number of rows. That's interesting. Like, I believe, I didn't know that you can do it like this, because the way that we did it before was that we just had this blank and we got rid of this. And then we had two global variables and another one for rows. That's how we did it before, right? But apparently this is acceptable. I actually didn't know that you can do that. So the number of columns has to be the same, but the rows can change. Okay. But that's okay. So the way that we're gonna
Hey, por favor, puerta.
I'm sorry? Oh, okay. The way that we have to write this this function is that we have wait a minute.
Doesn't the function have to take two arrays as a parameter since it's comparing them to each other?
Yeah, I did the same. I put in two arrays.
Oh yeah, you're right. Okay, I'm confused now. Maybe. Okay. All right, I'm not gonna. Here's what I'm gonna do. You won't see me do this too often, but I'm going to put the code that Professor Amir gave me in here, and then we can try to look at it together. Oh, we need this too. Yeah. So let's try to figure out how this works. Checks whether all elements in a two-dimensional array are identical.
Is that the same code from before?
No, this is the solution. This is the solution that Professor Amir gave me.
Oh, I see. I was gonna go like, oh, I just erased all the old solution.
Yeah, no.
This code,
This just looks like it points to the same thing.
yeah, it just kind of looks like it's checking whether or not every element in one array is identical. Like if the array is populated by the same number.
Wait, so we didn't misinterpret the instructions? It was the way we were thinking about it before?
No idea. Because if you look at his comments, his parameters say two-dimensional array to be searched.
Are you checks whether all elements in a two-dimensional array are identical? So it looks like, so it iterates through every row and then every column and then checks if one element is equal to the next.
Wait, so it's looking at if the elements in a row are identical. So say there's a row of ones, a row of twos, and a row of threes.
Right.
It's only comparing the row of ones with the row of ones.
Oh, it's checking to, I see. It's checking to see if So for an entire two-dimensional array, it checks to see if every element in one row is the same, and then every element in the next row is the same. Oh, that's what it's doing. I see. Okay. So now we understand what the instructions are. So I misinterpreted in two different ways, but now I understand. So so let me bring this out so that you guys will understand. So we have a 2D array, right? Let me do this. So you have that's it. So we have, let's just say we have a 2x3 2D array, right? So, or actually a 3x2. So I'm gonna say 1, 1, 1, and then 2, 2, 2. So this has 2 rows and 3 columns. So this is I'll use a different color. This is a 2x3 matrix. So what this code here is actually trying to do is it's checking to see if all of the, I'm going to use a different color for this. If all of the elements in the first row are the same, and then all the elements in the next row are the same. So because all the elements in row 1 is the same, it's all 1, and all the elements in row 2 is the same, it's all 2, this would return true, right? But if we didn't have that, like instead of having this, if we had something like this, like 0, 0, 1, 2, 2, 2. This is the same thing as a 2x3 array, but it's going to check to see if every element in this row is the same. Because we see 0 and then 1, we know that this is false. So this would return false. That's what this code is trying to do, right? Does everybody understand that that's what this is trying to do? It looks at each row individually. Yeah, because the way that I interpreted the first time was that I thought that every element in every row and column had to be the same. Like I thought that if it's 1, 1, 1, 1, 1, 1, this would return true. But no, it's looking at them like each row individually. That's what we do. That's the correct instructions. So my bad. Well, at least we know now, right? So yeah, so this is actually this is the function here. So it's a good thing that I showed this to you guys, because now we understand, right? So lucky for you, you now have the function, right? And there's no way that we can confuse the instructions this time, right? Because now we know what's going on. But
Honestly, I think that was the hardest part. Everything else is pretty much we can do, because that one was interpreting what is row.
yeah, you're right. But yeah, the last part of this question, we did write the function, the second part is writing a test code to see if 2D arrays see if they're identical, right? Let's we already did this. We might as well just finish this. So now that we have the function, let's go ahead and I'm gonna write some two-dimensional arrays to see like two different test cases just to see if they're identical. So I'll say int array. So how many rows do I want this array to have? Let's keep it small. Let's keep it 2. And as for the columns is fixed to 3. So I'm just gonna have to copy this, put it in 2. So this is basically a 2 by 3 two-dimensional array. So I'm gonna say, so 2 rows, 3 columns. Maybe I'll say 1, 2, 3. And then maybe I'll say 4, 5, 6. Now here's one 2D array, right? If we fed this to the function, this function here, of course it's gonna come out to be false because the numbers in this row are not the same and the numbers in this row are not the same. So this would return false, right? Let's make another 2D array that returns true. So int array. I'll keep it small again, 2 by 3. 2. Yeah, I'm real sorry, guys, for all the confusion. It's just I just wish that this question was a little more descriptive. If that were the case, we would not be running into this problem. So let's write a 2D array that returns true. So maybe I'll say 2, 2, 2, 2, and then 3, 3, 3. There should be a comment. Okay, so because all the numbers in this row are the same and all the numbers in this row are the same, we know that this would come out to be true, right? All right, so what we need to do now is
actually. Are you allowed to name both of them array?
Oh no, you're right, I can't. So I'll call this array A and call this array B. Thank you. I forgot to do that. Okay. All right. So now we can start. So now that we have two-dimensional arrays, we can feed them into this function and check and see if they are identical. So so here's what I'm gonna say. I'm gonna say if, because this is a bool, right? I'm gonna use a if statement for this bool. Okay. So if so and so, I'll go ahead and write that later. So this is the test for array A. So if the rows are similar, we'll say cout array A is identical. And then if it's not true, we'll say array A is not identical. Now, the thing that I'm going to put into this if statement is going to be the function. But instead of these, the first argument needs to be the array A. And the second argument needs to be the number of rows. So because in array A, the number of rows is 2, I'm going to say the number 2 here. So is everyone with me so far? You see, this function returns a bool. And a bool, as you already know, is a true false statement. So if this evaluates to be true, then I know that array A is identical. So I'll just say array A is identical. But if it's not true, like this evaluates to be false, this will be ignored. And we'll say array A is not identical anymore, right? So I'm going to actually put a comment here, test for array. And I can do something similar for array B as well.
Did you declare array A?
Oh yeah, it's right here.
Oh, okay. I think
keep
I
in
might
mind
have seen what I'd done. Okay, thank you.
Keep in mind that I completely made this up, just for the sake of testing. Did you get that, Valerie Moore?
I did. I see, because I did not see the A next to it, because I actually saw it inside the brackets instead, so that's why I got confused.
Okay. That's okay. So because I'm lazy, I'm just gonna copy this and change the instance of A to B. So I'll say array B, array B, array B, array B. And we can check to see if this works now. Let me save everything. Let's zoom out actually. So I have the function and the int main tests if it works. So what we should say is that since array A is not identical, this will be C-outed, and because array B is identical, this should be C-outed, right? Let's see. Yep. So array A is not identical, array B is identical.
Can you check on mine real quick, because it's still not doing the declaring?
Sure. Let me stop my share real fast, and then
Thank you.
and I'll give you permission to share. You can go ahead and share.
Okay. Yeah, because if you see the bottom one, what does this mean? Hold on.
Okay, so let's see what we got. Okay, so on line 20 and line 22, you said array A, and then inside the square bracket you put A.
Mhm.
You should actually put 2, because you got two rows.
Oh, so 2?
Yeah, same for that.
Oh, I see. Okay, let's fix that then.
Yeah, and that's why it's saying A and B was not declared in the scope.
Oh, I see.
Try
Okay.
it again. Let's see.
Okay, hopefully. Okay, so I just need to fix this then.
Line 14, it looks like. Oh, you're missing a semicolon. On line.
Oh, right here?
Yep, right there.
Okay. Let's
Oh, wait,
see.
oh, actually, no, my bad. It's not a semicolon. What you should say is that right after that, press enter once.
Okay.
Put open, close, squiggly brackets. and then say return false,
Oh, yeah, that makes more sense.
and then
Hold on.
in that function, right between the last two closing squiggly brackets, you should say return true.
Okay.
Like right between lines 19 and 20, you should say you should add a new line that says return true.
Okay.
Press enter once, say return true.
Oh yeah, that makes sense. Oh.
Yeah, because the moment that you see that two values are not identical, you already know right away that it's false, so we'll immediately return false. But if we if we look through the entire 2D array and
Right.
find that everything is similar, then we know that everything's similar and we can return true.
Oh, I see. Yeah, that makes a lot of sense. Thank you so much.
Yeah, no problem. Go ahead and stop your share now.
Yeah.
Okay. Let me put this back and share share my screen again. Yeah, so after all of that, yeah, this is the correct code now, not the thing that we were doing before. This is correct now, because I misinterpreted the instructions. So if everyone goes ahead and gets this already, if everyone's good, then we can just move on to the Zybooks now. I'll scroll up. Can you zoom in onto line 13? Sure, Slayman Toki. Okay. Did everyone get the code already? Are we good to move on?
Can
Go
you
to main?
scroll
Okay.
down? Oh yeah.
I'll zoom out too so you can see the full thing.
Thank you. Yeah, mine it works, but it's telling me both are not identical.
What does your two example arrays look like?
I think I pretty much just did the same thing you did just to do it for now, and then I was going to change it up later just to play with it. But let me just.
Do you want to share your screen and we can look at it?
Oh no. I can very easily. I can look through this and find my mistake. I just need to. It's probably going to be one tiny little thing.
Okay.
That's usually how it is when I type too quickly and I go back and I find about as many spelling errors as humanly possible.
I do that too. Okay, so
thank you.
Yeah, you're welcome. So did everyone get this already? Are we good to move on to the Zybooks now? If no one says anything, I'll just assume that everyone's good. Okay. Okay. All right. So I'm really, really glad that we got this resolved. I would really hate it if you guys lost points because I misinterpreted the instructions. But don't worry, we got this resolved now. So I'll just minimize this. Let's pull Zybooks open. Actually, let me find my Zybooks real fast. All right. Okay. Okay. Now, I know that we do only have like 10 minutes left in the session, but let's just try to get through as much of pointers as we can. And honestly, the week 10 material is just a continuation of the week 9 material. I believe you learned the basics of pointers. You learned the new and delete operators, and then you used a linked list, and all the labs here involve the linked list. But now we're going to learn about destructors, memory leaks, No, I actually don't use these too often, but that's okay. Well, this will be a learning experience for both of us, actually. So, all right. So, same deal as before. We'll try to get through as much of this as we can, and then whatever sections we don't accomplish in this meeting time, you'll be expected to do yourself over the weekend. So, 10.1 is destructors. A destructor is a special class member function that is called automatically when a variable of that class type is destroyed. C++ class objects commonly use dynamically allocated data that is de-allocated by the class's destructor. So for example, a linked list class dynamically allocates nodes when adding items to the list. Without a destructor, the linked list nodes are not de-allocated. The linked list class destructor should be implemented to de-allocate each node in the list. So this whole thing with destructors, it pertains more towards the linked list data structure that you were looking at in the previous week sections. So you already know how linked list works, hopefully. Each node consists of two parts. One is the data of that node, and the second part is a pointer variable that points to the very next node in the list, right? Now, the nice thing about having a linked list is that it's dynamically constructed, right? Meaning that you can add more nodes to the list or remove nodes from the list. But when you remove nodes from the linked list, you run into a little problem because every time you declare some sort of variable in memory, that node takes some space in memory, right? If you decide to like remove nodes from the linked list, like say, I don't need this data in this linked list anymore, I'm going to remove it, or actually break the link to that node. The problem is the memory that's allocated by that node is still allocated by that node. So the purpose of destructors is to free up that memory so that it can be used again for something else. Okay. Now this participation activity here, it shows just how destructors work, right? So I'm gonna go ahead and start. Okay, so we have a linked list, and we know it's a linked list because we have the referencing operator here, right? And we say list1 equals a new linked list, right? So we have a head node that's pointing to null right now, right? Because when we declare this, that's the only thing we have. We only have the head node, right? Now here we go. We went ahead and added 2 new nodes to this linked list, right? The data is here, and then the pointer that points to the next node is here, right? Without a destructor, deleting list1 only deallocates the list1 object. In other words, the only memory that gets deallocated is the head node, right? But without a destructor, these 2 nodes are still taking up space in memory, despite the fact that we no longer need it anymore, right? So that's going to be a problem if you try to use a linked list for one of your programs, right? So let's answer these questions. Using the delete operator to deallocate a linked list object automatically frees all nodes allocated by that object. What do we think? True or false? Well, we already know what the answer is, right? We saw in this example that only the head got de-allocated, but its child nodes did not. So obviously this is going to be false, right? A destructor for a linked list class would be implemented as a linked list class member function. How do you feel about this? True or false? It would be true, right? Because a constructor for a class is a function. So it only makes sense that a destructor is also a function as well. So I'm going to say true. And I know you haven't learned classes yet, but at some point you will. Maybe if you really wanted me to, I can do a quick tutorial about what classes are all about, but that's okay. We don't need to know that much about classes right now. Question 3 says, if list 1 were declared without dynamic allocation as shown below, no destructor would be needed. What do we think about this question? True or false? What do you guys think? I would think that the answer is true. No. Let's see what it's. Even if the list itself isn't dynamically allocated, the list nodes are. Okay. Yeah. The answer to this is false. Okay. So the next section says implementing the linked list class destructor. The syntax for a class's destructor function is similar to a class's constructor function, but with a tilde prepended into the function name. The destructor has no parameters and no return value. So the linked list node and linked list class destructors are declared as this and as this. Okay. The linked list class destructor is implemented to free each node in the list. The linked list node destructor is not required, but is implemented below to display a message when a node's destructor is called. Using delete to free a dynamically allocated linked list node or linked list will call the object's destructor. So we can see here. So here is the class for a linked list node, right? So under public, we have several public functions. This is the constructor, and this is the destructor, right? As noted by the tilde. And then we also have member data, which is the data, which is a type int, and then the pointer variable that points to the next node, right? So this is the code for the class linked list node, and this is the code for the class linked list. Okay. So here's the next participation activity. Let's run this and see what's happening. Okay, so it looks like here in the int main, we created a linked list, right? And then we have a for loop that iterates 5 times, right? And each time we're adding a new node to the linked list whose data is going to be equal to the index times 10. So in the first iteration, we're going to add 10 to the linked list, then 20, then 30, then 40, then 50, because that's how it works. Okay, let's see what happens next. Deleting the list calls the linked list class destructor, right? So on this line here, we deleted the list, right? Now, the destructor deletes each node in the list. So So if you tried to run this line of code here without having the destructor here, only the head would be deleted, but all the other nodes would still be allocated in memory, and you don't want that, right? And then, all right, let's see what else is next. Yeah. The destructor deletes each node in a list. After calling the destructor, the delete operator frees memory for the linked list head pointer. All memory for the linked list has been freed. Okay, so if we actually, I'm going to go back to step 3. If we actually, let's take a good look at the destructor code and try to understand what's happening, right? So it says while head in parentheses, right? Well, for a while loop, the thing that you put inside of the parentheses has to be something that you can interpret as a true or false statement. So, so by saying while head returns a Boolean value, like false if there's something there. Oh no, true if there's something there, and false if there isn't something there, right? So this this code is basically saying while there's something there to delete, delete it, and then move on to the next one. So this one says linked list node next equals head.next. Okay, so what this is actually doing is actually I'm gonna use paint again. So here's what I'm gonna do, so you guys have a better understanding of what's happening. So imagine I have a linked list, right? So this is my head, and then I have a series of nodes, right? So what this code is saying is that so what this is saying is that linked list, it's declaring a linked list node called next, which is equal to the node that head is pointing to, right? So we're gonna say that this is equal to, we'll say that this node here is equal to next. That's what this line of code is doing, right? Now it says delete head. So when this line of code occurs, what we do is we delete this node, right? Right? So now that's gone. And then it says, now we say that head equals next, right? So now we say that this becomes the new head, like head, right? And eventually, as long as there's something to delete, it'll continue doing this delete nodes until there's absolutely nothing left to delete. Because when we reach the end of the linked list, head will interpret to 0, which means that this while loop will return to false. That means that when this happens, we've deleted the entire linked list and there's nothing left to delete. Okay, that's how a destructor works, right? Okay, so I'll put this back here. Okay, All right, so there's some questions here. So after the destructor is called, the list's head pointer points to what does it point to? We've actually seen it in the participation activity. After the head's deleted, what does it point to next? Wait, after what do you guys think the answer is? How many of you think it's null? How many of you think it's the first node or the last node? Yeah, it would point to null because we deleted that node and now it points to nothing, right? So when this deconstructor is called and when the linked list destructor is called, the linked list node destructor gets called for each node in the list. What do we think about that? Do we think it's true or do you think it's false? These are good questions, by the way. They really test your knowledge. You think it's true? I think it's true as well. Let's see. Yep. It has to because the way the destructor for this works is that this destructor is called for each and every node in the list. It has to in order for every node to get deleted, right? And then lastly, question 3 says, if the linked list class were renamed to just list, the destructor function would be redeclared as what? List class. What do you think the answer is to this? Okay. The middle one? I think so too. Yeah, because a destructor is not of any type, right? You just say the name and then you have to have the tilde there as well to indicate that it's a destructor, right? Now, we've actually gone over time here. I think this is a good stopping point, right? I think you guys can do the rest of this on your own. What do you guys say? Because we are over time. Yeah. Okay. So all right, so I'm gonna go back to the home page. So since I guess over the weekend you guys can do sections. You guys can finish this section here that we started, and then you can do sections 2 through 5 on your own, so that when we meet again on Tuesday, we can start looking at the lab. We good? Okay. I'm gonna stop my share. Okay, perfect. So please, be sure to do those sections on your own time, so that when we meet again next Tuesday, we can start doing the lab together. Thanks for coming, everyone. I'll see you guys Tuesday.